Okay guys, here's a couple sheets that'll help you in going over your problems for your Blizzard Day number 2. Again, remember that's page 294, numbers 1 through 4 in the book, and page 319, 27 through 29. On page 319 you're going to have to click on the blue box to get those questions to appear. First thing is nuclear equations. Now nuclear equations, you're going to want to have the following items. An alpha, with this symbol here, is 4 over 2, a helium. A beta, with this symbol here, Greek letter B, is 0 over minus 1, an electron. A gamma, this symbol here, is 0 over 0, gamma. And neutron is 1 over 0, neutron. Those are kind of the special circumstances in writing nuclear equations. Now when we write a nuclear equation, what we want to end up having is the left side equal the right side. So for the first one, it's 219 over 86 Rn. This would be considered to be alpha decay because a helium 4 over 2 is breaking down. So if you notice here, 215 plus 4 equals 219. 84 plus 2 equals 86. The number of atoms on the left side and the right side must be equal. And all you have to use is your periodic table to find out what 84 is. 84 being PO polonium, 2 being helium. The 2 represents the atomic number, which is the integer on the periodic table. The second example I gave you is 3 over 1H yields 3 over 2He plus 0 over minus 1E. 2 plus minus 1 equals 1. 3 plus 0 equals 3. 3 plus 0 equals 3. So this would be an example of beta decay, because the electron is coming off. And again, notice the number of atoms on the left equals the number of atoms on the right. The next example I'll give you is 1 over 0n plus 235 over 92u equals 92 over 36 kr plus 141 over 56 ba plus 3 1 over 0n. So what we have to do is we have to add these up. 92 plus 141 plus 3 times 1 is 3, should equal 236. And then on the bottom side, 36 plus 52 equals 92, and that equals 92. So again, the atoms on the left and the right equal. And in a problem, what you'll be doing is you'll be given, like for this example problem here, you'd be given 2 of the 3 numbers. You'd have to find the third element, or subatomic particle. For the last example I have here for you, 129 over 53 iodine equals 129 over 54 Xe plus 0 over minus 1E. And again, the top number, the number of protons and neutrons, the mass number is 129 on both sides. And if we take 54 plus a minus 1 equals 53, so the atomic number is the both on same sides. That is how nuclear equations work. The second problem set on page 319 will deal with half-lives, which is abbreviated HL or capital HL. Half-life is the time it takes for 1/2 of a sample to decay. So for example, if we had 3 half-lives, we take a half times a half, which means an eighth would be left, or 7/8 has decayed. So the sample problem I'll give you here is, in 24 grams, how much is left after 4 half-lives? We would take a half times a half times a half, which would be 1/16 is left. You can express that as a fraction or in decimal form. Either way is fine. When you punch in the calculator for problems, you're going to need eventually convert it to decimal form. So if we had 24 grams to find out how much is left, we would take 1/16 times 24, and we get 1.5 grams left, which means that of that original 24-gram sample, 22.5 grams decayed. Again, if you have any questions, feel free to email me throughout the day. Every few hours I'll be checking that and responding back. We hope to see you tomorrow.